of h approaching 0 or cosine h minus 1 over h. It sure looks like it is 0 over 0 now, doesn't it? Because once you substitute 0, this cosine becomes 1 minus 1 over h is 0. Well, like everything else in this class. But then you notice by now that the derivative that we've been evaluating is a 0 over 0 type of limit. So that's kind of what it is all about. Now, whenever, see, cosine is usually a radical number, isn't it? Meaning, whenever you have radicals in the limit, what is the common technique? You multiply conjugate looking thingy, as you might have figured out in figuring out the half angle for tangent. Yeah, this technique works really well. So let's see what this thing becomes. So this is a limit of h approaching 0 of the numerator is cosine squared h minus 1 squared over, and we never distribute. So far so good? Now, somebody tell me what the numerator is. Oh, come on, people.
Sine squared.
Sine squared, well, almost. Negative sine squared,
Negative.
right? Which I'm going to write it like that. Good? Right? 1 minus cosine squared is sine squared. So cosine squared minus 1 better be negative sine squared. And now, as soon as I write it like that and limit on both of them, do you see this is 1? Well, negative 1, because we have that negative sign. And then this. Let's look at it. The numerator approaches 0 over denominator becomes 2, doesn't it? Which is 0. So our answer to this is 0. Okay? Why would we start the class with that kind of exercise? This is like a cooking show, okay? This is a sauce that I prepare, and we're gonna let it marinate on a corner of the kitchen, okay? Let's start cutting the meat, all right? Okay, so next prompt says, oh, that means numerical derivative. I showed you how to compute the numerical derivative at a point, right? Find the slope. Yeah. So let's, didn't want you to see that. Go here and put sine x here. Okay, I'm going to show you how to put the next line. So sine x. So make sure you're in radian mode. Calculus is only done in radian mode. We'll never do degree in this class. Okay. Now, this one, math, and 8 is the hotkey. You can just press 8, but I'm going to show you set and derivative. That's this thing, numerical derivative. You get it? Okay. So press enter or hotkey math 8. Then this shows up. And this is pretty intuitive, right? X goes here and there. We can put sine x, but actually let's put y1. That's convenient. That way later we can just change this, and because we're going to figure out cosine as well. And then this is always the derivative of y1. You get it? So y1 can be done this way, second, and trace, and there's your y1. You get it? Now, here, we used to put a number here. Where do you want to evaluate the slope? Like pi over 6, pi over 4. This time, since we're graphing it, put x there. What you're telling this computer to do is, see, when it computes graph sine x, it computes every single little points and then it's connecting them, right? You're telling it to do exactly the same thing at every single point, figure out the slope and connect those as well. You get it? You ready? And remember, whenever you're graphing trig, zoom 7, right? Zoom 7, bang. So here comes the derivative of sine, as we know, and here comes the derivative of cosine. You recognize it? Do you recognize this? Can somebody please say you recognize it and tell me what it is? Feel free to use your microphone and make a good impression on your teacher.
I recognize
The derivative cosine.
No, yeah, the derivative is cosine now, isn't it?
Yeah.
It wasn't that hard. Right? You're just shy. Okay. So derivative of sine is cosine. So much for the power rule, right? Whenever I relieve you from that burden of difference quotient and give you the power rule, then this happens. Yikes. Okay, well, then could we have a conjecture? What do you think is the derivative of cosine then? We can just change that one thing and then it'll show us. Feel free to take a guess before I hit this graph button. Okay, here's cosine and derivative. Could it be sine? Here it comes. Here she comes, right? That's not quite sine. What is that thing? Somebody
Negative sign.
That is negative sine. Wow, derivative of cosine is negative. Ah, this is a weird rule, right? Okay, but we have enough reason to believe, right? Okay. Now, time to, that's a preview. Like we are watching YouTube video, cooking video on YouTube. Now let us cook. So we did B part. So C part here. C part is limit h approaching 0. Oh, let me write down the title. Derivative of sine x is equal to, according to the definition, this is it. Difference quotient, eh? Okay. And then seems like we're stuck right away. Because what do we do after this, right? Somebody give me a brilliant suggestion. We just said an identity.
Stand.
Identity.
Aha, this identity, right? You see why I felt so passionate about this identity? Now you all understand what this is, right? Because if I didn't really give you that identity quiz, then you'd have been stuck. What? Where did you get that? Now, no problem. Everybody gets this, right? Other than few of you who got negative 80. Okay, then. I'm gonna rearrange it. So the first term minus the last term, I'm gonna put it together like that. And then I'm gonna put this middle term. Still with me? Too much algebra? That middle term right there is here. Now I see common factor. So I'm gonna factor that. Sine of x, and then we have cosine of h minus 1 over h plus, and then cosine, I'm going to write it like this, and then sine h over h. As soon as I write that, now you almost recognize this thing. This thing, why does it look so familiar? That is the sauce that's been marinating from the beginning, right? That's 0. Okay, that's nice. So this becomes 0. And then this, of course, is 1, eh? Remember, sine h over h as h approaches 0. So what we have is first term sine, it does not have h in it, so it is sine x times 0 plus cosine x times 1, eh? So as we believe, we have cosine of x.